The process begins with shuttering, where formwork is installed to shape and support the foundation slab. A waterproof membrane is laid over the prepared area to prevent moisture ingress. Reinforcement bars, rebars, are strategically placed within the shuttering. These provide tensile strength, critical for the durability of the foundation. Once the preparatory steps are complete, the foundation is ready for concrete pouring. The concrete is carefully poured into the shuttered foundation area, ensuring it flows evenly around the reinforcement bars. Vibrators are used to eliminate air pockets, enhancing strength and structural integrity. Leveling and troweling: the poured concrete is leveled and troweled to ensure a smooth and even surface, free from irregularities. After curing, the foundation slab is complete, forming the base for further construction. The installation of floor panels involves carefully placing prefabricated concrete panels over the twin wall panels that form the basement walls. These panels serve as the basement ceiling and the ground floor base. Each panel is positioned precisely using cranes or lifting equipment, ensuring alignment and stability. Connections between the panels are sealed to create a uniform surface, and temporary supports may be used during the installation. Installation of floor panels: floor panels are positioned above the twin wall panels, establishing the basement ceiling and support for the ground floor. Concrete is poured into the cavity between the twin walls, solidifying the structure and ensuring stability. The basement structure is now complete, providing a secure underground space. Measurements and markings are done to outline the ground floor slab accurately. Footings are prepared and shuttering is installed for the ground floor slab. Placing of foul drainage pipes: drainage pipes are installed for managing wastewater, ensuring functionality. Concrete frost protection layers are poured to safeguard the structure against freeze-thaw cycles. Similar to the foundation, membranes and spacers are added for moisture protection and reinforcement placement. Placing of reinforcement bars are positioned for the ground floor and basement slabs. Pouring: ground floor and basement slab concrete is poured over the prepared ground floor and basement slabs, binding the structure cohesively. Completed baby basement with ground floor slab: the baby basement construction is finalized, providing a robust and versatile space beneath the ground floor slab. This method combines efficiency with affordability, meeting diverse architectural and functional needs. The process begins with precise excavation of the construction site to the required dimensions, ensuring a stable base for the basement. Temporary shuttering is installed to form the outline of the foundation slab. A protective membrane is laid on the excavated surface and inside the shuttering. Steel reinforcement is positioned within the shuttering to strengthen the foundation slab. This reinforcement improves the slab's load-bearing capacity and ensures structural integrity over time. Concrete is poured into the shuttering, encasing the reinforcement. The slab is left to cure and harden, forming a strong and stable base for the basement. Once cured, the foundation slab is complete. The layout of the basement walls is marked on the foundation slab. Installation of external precast twin wall panels and internal precast walls. The installation of precast twin wall panels begins with carefully positioning the external panels along the marked layout on the foundation slab. These twin wall panels consist of two reinforced concrete shells connected by steel ties. leaving a cavity to be filled with concrete later for added strength. The panels are precisely aligned and temporarily braced to ensure stability during installation. Simultaneously, internal precast walls are installed, forming the interior structure of the basement. These panels are factory-made to exact dimensions, ensuring a seamless fit. Precast panels for the ground floor are placed atop the walls. These panels provide the ceiling for the basement and the floor for the ground level of the house. Temporary support of ground floor slab. Temporary supports are erected to hold the ground floor slab panels securely until they are permanently fixed. Reinforcement of ground floor slab. Reinforcement is added to the ground floor slab to enhance its strength and load-bearing capacity, ensuring it can support the structure above. Once the twin wall panels are securely installed, the cavities between their reinforced concrete shells are filled with high-strength concrete. This process bonds the walls into a solid monolithic structure, enhancing their stability and load-bearing capacity. Concurrently, the reinforced ground floor slab is concreted, ensuring a seamless connection with the walls below. Careful pouring and leveling of the concrete ensure a smooth finish and uniform strength, creating a robust foundation for the upper structure of the building. Concreting twin wall cavity and ground floor slab. Concrete is poured into the cavity of the twin walls and over the reinforced ground floor slab, binding the structure together and creating a solid, unified base. Sealing. Vertical joints. Vertical joints between precast panels are sealed with precision, ensuring a seamless and watertight finish. External waterproofing and insulation. External surfaces are treated with bitumen tanking and covered with insulation to enhance waterproofing and thermal efficiency. A drainage sheet and backfill protection are added to safeguard the basement from external pressure and moisture. Glatthaar Fertigkeller's innovative approach ensures high-quality, durable basements that provide comfortable living spaces and a solid foundation for any home. The bustling city of Portsmouth, renowned for its vibrant maritime history, is now home to a groundbreaking residential project that combines innovative engineering, sustainable technologies, and cutting-edge design. This new build project features an ambitious basement construction and incorporates advanced energy-efficient systems to establish a benchmark for modern, eco-friendly living. EarthSafe Products is proud to contribute to this project with its state-of-the-art heating and energy solutions. This new build project is not merely an architectural feat, but a testament to the potential of green construction. Designed to provide comfortable, energy-efficient living, the house integrates several sustainable technologies to minimize its carbon footprint while enhancing energy independence. Central to this project are the bespoke underfloor heating system, integrated MHVR, mechanical heat recovery ventilation, and a photovoltaic power system complemented by Tesla's PV power storage battery. An integral aspect of this development is the basement construction. Basements, often underestimated in residential projects, offer a range of advantages: additional living or storage space, improved thermal insulation, and a higher property value. However, basement construction requires planning, advanced engineering, and a focus on structural integrity, especially in areas like Portsmouth, where coastal conditions can pose unique challenges. Basement construction in this project has been undertaken with precision, focusing on durability and sustainability. It serves as a multifunctional space that enhances the home's utility while ensuring thermal efficiency. Engineers have utilized modern techniques such as waterproofing membranes, reinforced concrete, and sustainable building materials to ensure the basement withstands ground pressure, dampness, and seasonal changes in soil conditions. Basements inherently contribute to a home's energy efficiency due to their thermal mass properties, which help regulate indoor temperatures. Coupled with innovative heating and ventilation systems, this basement will not only provide a comfortable environment, but also reduce the overall energy consumption of the property. EarthSafe Products' cutting-edge contributions at the heart of this project's sustainable ethos is the suite of energy solutions provided by EarthSafe Products. Especially, we are proud to supply our ESP Heliotherm Sensor Comfort Compact underfloor heating system, 300-liter EcoScent, and support the implementation of an MHVR system. These elements work cohesively to enhance energy efficiency, reduce emissions, and deliver a superior living experience. ESP Heliotherm Sensor Comfort Compact, 8 kilowatts at -7 degrees, the underfloor heating system, powered by the ESP Heliotherm Sensor Comfort Compact, is a hallmark of energy-efficient heating. This compact yet powerful system is designed to deliver consistent warmth across the home, even in extreme temperatures. With an output of 8 kilowatts at -7 degrees Celsius, it ensures reliable performance during the harshest winter months. The underfloor heating system operates by distributing heat evenly across the floors, eliminating the need for traditional radiators and freeing up interior space. By using low-temperature water, it maximizes efficiency and reduces energy costs while ensuring optimal comfort. The 300-liter EcoScent water heater is another revolutionary addition to this project. Designed to recover and reuse heat from the house's ventilation system, it acts as a bridge between comfort and sustainability. Integrated into an MHVR system, the EcoScent captures otherwise wasted heat and repurposes it for domestic hot water needs. This reduces energy usage and reliance on external heating sources, making the home more self-sufficient. Sustainability is further amplified with the installation of a 4 kilowatts photovoltaic PV array on the property. This solar energy system generates clean, renewable electricity, significantly reducing reliance on the grid. Complementing this is the Tesla PV power storage battery, which stores excess energy generated during the day for use during the night or cloudy periods. This not only enhances energy security, but also maximizes the value of the PV array. By combining solar power generation with advanced storage solutions, the home is equipped to manage energy more efficiently, reducing both electricity costs and environmental impact. The integration of these systems reflects a holistic approach to sustainability. The combination of basement construction, advanced heating and ventilation, and renewable energy solutions ensures that this Portsmouth property meets the demands of modern living while remaining environmentally responsible. Sustainable technologies like the Heliotherm underfloor heating and EcoScent with MHVR contribute to significant reductions in greenhouse gas emissions. Furthermore, the PV array and Tesla battery exemplify the growing shift towards decentralized, renewable energy systems that promote energy independence and resilience. The construction of a Glatthaar notary house in Berkel and Schott. The construction of a notary house on a new Warande plot in Berkel and Schott is a fascinating example of modern, efficient, and sustainable building techniques. This particular house, built by Glatthaar from Emmeloord, showcases the seamless integration of energy-efficient technologies and rapid construction methods. Captured in a video report, the entire construction process, from foundation piling to the placement of the final rooftop tiles, is condensed into an engaging 33-minute time-lapse. Here, we delve into the unique features of this project, the innovative techniques employed, and the significance of its eco-friendly design. A modern masterpiece by Grotus Bau. Grotus Bau is a renowned construction company specializing in high-quality homes built with precision and efficiency. For this project, they undertook the ambitious task of constructing a notary house in just 6 days. From February 12 to February 21, 2019, the company demonstrated its capability to execute complex construction processes with exceptional speed and accuracy. The notary house stands as a testament to Grotus Bau's commitment to combining traditional architectural elegance with modern engineering. Notary houses, known for their timeless charm and stately appearance, typically feature symmetrical facades, steeply pitched roofs, and a classic aesthetic. This house retains those qualities while embracing contemporary, sustainable solutions that ensure it is ready for the future. Key features of the notary house. This notary house is not just a visual delight, it is also an exemplary model of sustainability and energy efficiency. Several key features make it a standout project. Energy efficiency. The house is designed to minimize energy consumption, making it environmentally friendly and cost-effective for its occupants. It is entirely gas-free, a crucial step in reducing dependence on fossil fuels. Ceramic solar roof tiles. A highlight of the house is its innovative roof, fitted with ceramic solar tiles from Zepp BV, a company based in UK. These tiles blend seamlessly with the roof's aesthetic while providing renewable energy. Unlike traditional solar panels, these solar tiles maintain the roof's classic appearance, staying true to the notary house's architectural style. Geothermal energy and heat pump. The house utilizes 2 geothermal energy sources paired with a state-of-the-art heat pump system. This combination harnesses the Earth's natural heat to provide sustainable heating and cooling solutions, reducing the home's carbon footprint. Rapid construction. The 6-day construction timeline is nothing short of remarkable. It reflects meticulous planning, precise execution, and the use of prefabricated elements to streamline the building process. The construction process. The entire construction of the notary house is documented in a 33-minute time-lapse video, offering viewers an impressive overview of how such a complex structure comes together in just a few days. Below is a breakdown of the main stages, foundation and piling. The process begins with foundation work, which includes drilling and placing foundation piles to ensure structural stability. This phase is critical as it sets the groundwork for the rest of the build. Assembling the frame. Grotus Bau's prefabricated components play a pivotal role in accelerating the construction timeline. Walls, floors, and other structural elements are delivered to the site and quickly assembled like pieces of a puzzle. Roof installation. The roof is installed and fitted with the ceramic solar tiles from Zepp BV. These tiles are carefully integrated to maintain the roof's traditional look while adding a functional, eco-friendly layer. Interior finishing. The interior of the house is completed with equal efficiency, including the installation of insulation, wiring, plumbing, and finishes. The use of pre-planned layouts ensures a smooth workflow. Final touches. Landscaping and exterior details are added to complete the house, making it ready for occupation. The entire process is a fine example of how modern construction methods can combine speed, quality, and sustainability. Sustainability and innovation in practice. The notary house exemplifies a shift towards more sustainable building practices. The inclusion of solar roof tiles and geothermal heating systems highlights the increasing emphasis on renewable energy sources in residential construction. These features not only contribute to a lower environmental impact, but also result in long-term cost savings for homeowners. The decision to go gas-free is particularly notable, aligning with broader global efforts to phase out natural gas in favor of cleaner alternatives. By eliminating reliance on gas, the house is future-proofed against potential regulatory changes and rising energy costs. Challenges and achievements. Building a house of this caliber in 6 days is no small feat. The project required extensive coordination between architects, engineers, and construction crews. Prefabrication was a key strategy, allowing major components to be manufactured off-site and assembled with precision on location. Another achievement lies in the integration of cutting-edge technology without compromising on aesthetics. The ceramic solar roof tiles, for instance, maintain the classic look of the notary house while delivering modern functionality, a balance that is often difficult to achieve. The time-lapse video documenting the construction is a valuable resource for both professionals in the construction industry and potential homeowners. It provides insights into the efficient methodologies used by Glatthaar, demonstrating how advanced planning and innovative techniques can significantly reduce construction timelines. For viewers, the video transforms a complex, time-intensive process into an engaging and accessible narrative. Watching the house come to life in just 33 minutes is a powerful reminder of how far the construction industry has evolved. The Glatthaar Notary House in Berkel is more than just a building. It is a symbol of what modern construction can achieve. By blending timeless design with sustainable technologies and rapid construction techniques, this project sets a benchmark for future developments. From its energy-efficient features to its rapid assembly, the Notary House embodies the principles of sustainability, innovation, and craftsmanship. It serves as an inspiration for architects, builders, and homeowners looking to embrace greener living without compromising on quality or style.